गुड इवनिंग स्टूडेंट्स। लास्ट लेक्चर में हम लोगों ने डिस्कस किया था टॉर्जन ऑफ शाफ्ट्स, सर्कुलर शाफ्ट्स, सॉलिड शाफ्ट्स एंड हॉलो शाफ्ट्स। टॉर्जन इक्वेशन ड्राइव किया था और सर्कुलर शाफ्ट, सॉलिड शाफ्ट के लिए और हॉलो शाफ्ट के लिए, और एक दो न्यूमेरिकल सॉल्व किए थे। कुछ न्यूमेरिकल सॉल्व करेंगे इस टॉपिक पर हम। तो टॉर्जन और शाफ्ट पर ही प्रॉब्लम सॉल्व करेंगे आज। पहली प्रॉब्लम है टू शाफ्ट्स ऑफ द सेम मटेरियल and of same length. Two shafts of same material and of same length are subjected to the same torque, are subjected to the same torque if the first shaft is of a solid circular section, if first shaft is of a solid circular section and the second shaft is of hollow circular section whose internal diameter is diameter is 2/3 of outside diameter and maximum shear stress developed developed in each shaft is same. Compare the weights of shafts. Okay, two shafts of same material and the same length are subjected to the same torque if first shaft is a solid circular shaft section and second shaft is the hollow circular section. whose internal diameter is 2 by third of the outside diameter, and maximum shear stress developed in each shaft is same. Compare the weights of the shaft. Okay. Let capital T is the torque transmitted by each shaft. Torque transmitted by each shaft. Tau is the maximum shear stress. Developed in each shaft. Capital T is the outer diameter of solid shaft. Outer diameter of solid shaft, and DO is the outer diameter of hollow shaft. DI is the inner diameter of hollow shaft, and WS is the weight of solid shaft, and WH is the weight of hollow shaft. L is the length of the shaft, length of each shaft, and rho is the density of material of each shaft. Okay. Now torque transmitted by solid shaft, solid shaft, T will be equal to the pi upon 16 tau into d cube. T by J is equal to tau by R. J is equal to pi d to the power 4 upon 32. R is equal to the d by 2. So from here T will be equal to the pi d to the power 4 upon 32 into tau d to the d, R is equal to d by 2. So it will be equal to the d cube pi by 16 into d cube tau. Okay. This will be the torque transmitted by the solid shaft, and torque transmitted by hollow shaft T will be is equal to the pi by 16 into tau d outer to the power 4 minus d inner to the power 4 upon d outer. Okay, here d diameter of inner diameter of hollow shaft is 2 by third of the outer diameter of hollow shaft. Now replacing the value, T will be is equal to the pi upon 16 tau d outer to the power 4 minus 2 by 3 d outer to the power 4 upon d out, or T will be is equal to the pi by 16 tau d outer to the power 4 upon 16 on 81 on do. Okay, or T will be is equal to the pi upon 16 tau 65 upon 81 d outer to the power 4 upon do, or T will be is equal to the pi by 16 tau into 65 upon 81 d outer to the power 3. Okay, as torque transmitted by the solid and hollow shaft are equal, so pi by 16 tau d to the power 3 will be equal to the pi by 16 tau into 65 upon 81 d outer to the power 3. This will be equal to the d to the power 3 will be 65 upon 81 d outer to the power 3. Clear? Or from here d will be equal to the 0.929 outer diameter of hollow shaft. Okay, now weight of solid shaft Ws will be equal to the density of the shaft multiplied by volume of the shaft. Clear? So from here Ws will be equal to the density is rho, volume of the shaft is pi by 4 d square into L. Now weight of the hollow shaft, hollow shaft Wh will equal to the density into volume. Now Wh will be equal to the rho into pi by 4 d outer to the power 2 minus diameter of inner circle multiplied by L. This will be the volume of the hollow circular shaft. Now as we know that D, the inner diameter of the hollow shaft is equal to the 2 by 3rd of the outer diameter of the hollow shaft. WH will be equal to the rho into pi by 4. Diameter of outer diameter of hollow shaft minus 2 by 3 into L. Okay, or WH will be equal to the rho pi by 4 into 5 by 9 into outer diameter of the hollow shaft into length. Clear? Now dividing the weights of the solid circular shaft and hollow circular shaft, it will be equal to the density pi by 4 d square into L divided by density pi by 4 into 5 by 9 outer diameter of hollow shaft into length. It will be equal to the 9 d square upon 5d outer diameter of hollow shaft. Now Ws upon Wh will be equal to the 9 by 5 into 0.929 outer diameter of hollow circular shaft upon d. This will Ws upon Wh will be equal to the 1.55 by 1. So the weight ratio will be equal to the Ws will be equal to 1.55 of Wh. अगर सेम मटेरियल के शाफ्ट से पावर ट्रांसमिट करनी हो सॉलिड सर्कुलर शाफ्ट से सेम टॉर्क सेम शियर स्ट्रेस का और सेम लेंथ की, तो इस केस में सॉलिड सर्कुलर शाफ्ट का जो वेट होगा वो 1.55 टाइम्स होगा हॉलो सर्कुलर शाफ्ट में, जिसमें उसकी इनर डायमीटर 2/3 है उसके आउटर डायमीटर की. ओके, नाउ एक क्वेश्चन सॉल्व करते हैं, एक प्रॉब्लम. ए hollow circular shaft of 20 mm thick, a hollow circular shaft 20 mm thick transmits 300 kilowatt power at 200 rpm. Determine the external diameter of shaft if the shear strain due to torsion is not exceeds 0.00086. Take G, modulus of rigidity, is equal to the 0.8 into 10 to the power 5 Newton per mm square. Okay. Question is, a hollow circular shaft 20 mm thick transmits 300 kilowatt power at 200 rpm. Determine the external diameter of the shaft if the shear strain due to the torsion is not exceed 0.00086. Take modulus of rigidity G is equal to the 0.8 into 10 to the power 5 Newton per mm square. ओके, चलिए इस क्वेश्चन को, इस प्रॉब्लम को सॉल्व करते हैं. Given thickness T is equal to the 20 mm, power transmitted P is equal to 300 kilowatt, 300 to the power 10 to the power 3 watts. Okay, speed N is also given 200 rpm. Shear strain phi is equal to the 0.00086. Modulus of rigidity G is equal to 0.8 into 10 to the power 5 Newton per mm square. Let DO is the outer diameter of shaft and DI is the inner diameter of shaft. Then here outer diameter will be equal to the D inner plus 2 times of thickness. Clear? Or say D inner is equal to the D outer minus 2 times of thickness, which is DI is equal to the D outer minus 40. Clear? Now the power transmitted P is equal to the 2 pi NT by 60. Okay. Now power is equal to the 2 pi, RPM is 200. Torque can be calculated from here. Capital T will be is equal to the So torque will be equal to the 14323,900 Newton mm. Okay. Okay. We know that modulus of rigidity will be equal to the shear stress upon shear strain. Here modulus of rigidity is 0.8 into 10 to the power 5. Shear stress can be calculated because shear strain is given, which is 0.00086. So from here shear stress will be equal to the tau will be equal to the 68.8 Newton per mm square. Clear? Now the torque transmitted by the hollow circular shaft will be equal to the pi by 16 tau into d outer diameter of hollow shaft to the power 4 minus inner diameter of the hollow shaft to the power 4 divided by outer diameter of hollow shaft. Okay. Now T will be equal to the 14323,900 pi by 16. Shear stress is given 68.8. The outer diameter to the power 4 minus inner diameter to the power 4 upon the outer, or it will be equal to the 14323,900 into 16 divided by pi into 68.8. Outer diameter is equal to the d outer to the power 4 minus d inner to the power 4. Okay. It will be equal to 1060334.6 outer diameter du is equal to d outer to the power minus d inner to the power 4, or 1060334.6 outer diameter will be equal to the okay. We know that here d I is equal to the d outer minus 40. So from here 1060334 into outer diameter is equal to the d outer square plus d inner is d outer minus 40 square, d outer square minus d outer minus 40 square. Clear? Now solving this, Okay. यहाँ हमने सबसे पहले इक्वेशन को सॉल्व करने के लिए जो डायमीटर की वैल्यू ली वो 100 mm ली। 100 mm लेने पर जो इक्वेशन की वैल्यू है वो नेगेटिव आई। इसके बाद जब हमने डायमीटर की वैल्यू 108 mm ले रहे हैं तो यहाँ पर इसको सॉल्व करने पर जो वैल्यू आएगा वो आएगा 1149। तो जो वैल्यू होनी चाहिए डायमीटर की will be slightly less than 100 mm, 108 mm, slightly less than 108 mm आपका होगा। तो यहाँ पर ये जो स्ट्रेसेस हैं वो सेफली आपकी जो शाफ्ट है वो वर्क कर पाएगी। ओके। एक और क्वेश्चन सॉल्व कर लेते हैं हम लोग। ए सॉलिड cylindrical shaft is to transmit 300 kilowatt power at 100 rpm. Given a solid circular shaft is to transmit 300 kilowatt power. Power transmitted is 300 kilowatt. P is equal to 300 into 10 to the power 3 watts at 100 rpm. So speed of the shaft is 100 rpm. First, if the shear stress is not exceed to 80 Newton per mm square, so maximum shear stress tau is given 80 Newton per mm square. Find its diameter. Okay. Second, what percent saving in weight would be obtained if this shaft is replaced by a hollow one whose internal diameter is 0.6 times of external diameter, the length of the material and the maximum shear stress being the same. Okay, let capital D is the dia of shaft. Okay, now we know that power transmitted by the shaft is 2 pi nt by 60. Here power transmitted is 310 to the power 3 is equal to 2 pi, and RPM is given 100 mm, 100 rotation per minute. So we can calculate the torque. So torque is 28647,800 Newton mm. Okay. So from the torsion equation, T is equal to the pi by 16 tau d to the power 3, or implies 28647,800 is equal to pi by 16 into 80 d to the power 3. So from here d will be is equal to the 121.8 mm. Okay. Now come to the second part. Let DO is the outer diameter, DI is the inner diameter. Here inner diameter is 0.6 times of outer diameter. Now the torque transmitted will be equal to the pi by 16 into tau on the outer. Okay. Now T will be is equal to the pi by 16 into 800 d outer to the power 4 minus 0.6 d outer to the power 4 divided by d outer. So T will be is equal to the 2864 now 28647,800 will be equal to the pi into 50 0. This will be equal to 0.8704 d outer to the power 4 divided by d outer. So from here outer diameter will be equal to the 128 mm. Okay. So the inner diameter will be equal to the 76.8 mm. Now the ratio weight of the solid shaft will be equal to the density pi by 4 d square by L, d square into L. It will be equal to the and the weight of the hollow circular shaft WH will be equal to the density pi by 4 d outer square minus d inner square into length. Now the ratio of solid shaft and hollow shaft will be equal to the d square minus d outer square minus d inner square divided by d square. Wait a minute, it will be equal to the weight percentage. For determining the weight percentage, Ws minus Wh by Ws into 100. Okay, from here we will get this. So we know that value of diameters. Putting the value of diameter, it will be equal to the 29.55%. Okay, this will be the answer. Thank you so much.